Hi everyone. In this class, we are going to see a topic in engineering mathematics, namely differential calculus. So we are going to see introduction about this topic. So in this, we are going to see representation of functions, limit of a functions, continuity, derivatives, differentiation rules in this, sum, product, quotient, chain rules, implicit differentiation, logarithmic differentiation, and applications part, so maxima and minima of functions of one variable. So first we will see what is function. How will you define a function? So let x and y be two non-empty sets. We take two non-empty sets x and y. If there exists a rule f which associates to every element x in x a unique element y in y, then such a rule f is known as a function or mapping from the set x to the set y. So we consider two sets x and y. So if you take any element in x, there exists a unique element in y under the rule f, then such a rule is nothing but function. Sometimes it may be called it as mapping. If x belongs to x is associated to an element of y, then y is called image of x, and that x itself is called pre-image of y under the mapping f, and it can be written as y is equivalent to f of x. The set X is called the domain of F. The whole set X is called domain of F, and the whole set Y is called codomain of the mapping F. The set of all images under F is called range of F and is denoted by generally f of x. So every element in X, we have images, right? So collect all those images and we call it as range of f and is denoted by f of x. Now we see representation of functions. So there are four possible ways to represent a function. So first one is verbally, that is by a description in words. In words we are saying ellipse, parabola, straight line, hyperbola, and that by words we are representing a function. And second one numerically, which means we can represent by a table of values. For example, so we can represent a function, right? X, f of x in a table. So 0, 4, 7, and here 8, 10, 24. So we can represent in a table. So numerically we can represent. The third one visually, that is by a graph. So we can draw a graph, right? So that is for straight line we can draw a graph. So straight line y is equivalent to x. Similarly, circle, parabola. So by a graph we can represent. And finally, algebraically, so which means by an explicit formula. For example, so y is equal to x is a straight line, and y square is equivalent to 4ax, and the equation of circle. So x square, general x square plus y square is equivalent to a square. So by a formula we can represent a function, which means algebraically we can represent. Now we see some examples. The first one, find the domain of the following functions. So first one, f of x is equal to square root of x plus 2, and second one, g of x is equal to 1 by x square minus 1. So first we see solution of the first one. Here in the function we have square root. So since the square root of a negative number is not defined, that is if we have a within square root we have negative, so it is not defined. We come to the complex number system, but we are consider only here real numbers. So the domain of f consists of all values of x such that that inside value should be positive, that is x plus 2 is greater than or equal to 0, and it can be written as so x greater than or equal to minus 2, that is the value of x is greater than or is equal to minus 2, which means for example we consider minus infinity to plus infinity. So we have minus 2, so this side above minus 2, so that this can be represented by like this: closed interval minus 2 and open interval infinity. So the domain is nothing but minus 2 to infinity. For second problem, g of x is equivalent to 1 by x square minus 1. This can be written as 1 by x we can take outside, so x into x minus 1. Now we can observe that when we put x is equivalent to 0, what do you get? The function anything by 0 is nothing but infinity. The function is not defined. Similarly, x is equivalent to 1. So we substitute x is equal to 1, what will happen? So 1 by 1 minus 1, 0. So anything by 0, infinity. That is, the function is not defined. So x is equal to 0 and x is equal to 1, the function is not defined. So x cannot be take these two values 0 and 1. So in the real line, so for example minus into plus infinity, so 0 and 1, we exclude these 2 points and the remaining are all x can take, right? So we can write like this, minus infinity to 0. Okay, 0 excluded, 0 to 1, 1 excluded, so 1 to infinity. So in this way we can represent. So this is nothing but domain of the given function g of x. So simply we say means the domain is nothing but what are the possible x can take, possible values x can take. Now again we see one more example. So find the domain of the following function, which means f of x is equal to square root of 3 minus x minus square root of 2 plus x. So here also square root we are having. So in this, so the inside value 3 minus x should be positive and also 2 plus x should be positive. So here the same case, the square root of a negative number is not defined. The domain of f of x consists of all the values of x such that 3 minus x greater than or equal to 0 and x plus 2 greater than or equal to 0. So this is equivalent to x less than or equivalent to 3. So that this can be written as 3 minus x greater than or equal to 0 can be written as x less than or equal to 3, and x plus 2 greater than or equal to 0 can be written as x greater than or is equal to minus 2. So the value of x can be take in this in these two values, in between these two values, minus 2 and 3. So closed interval minus 2 to 3. And third one, find the domain and range and sketch the graph of the function f of x is equal to square root of 4 minus x square. So solution. So f of x we can represent it by y. So y is equivalent to square root of 4 minus x square. So square on both sides, what you get? Y square is equivalent to 4 minus x square. So that minus x square we take into left hand side. So we can get x square plus y square is equivalent to 4. So it is a well-known curve, right? So which represent a circle with the center at the origin and the radius is 2. I hope you know, everybody know the general equation of circle. So x minus a whole square plus y minus b whole square is equivalent to r square. So here radius is r and center is a comma b. So here we observe this. So here x square plus y square. So obvious, what is the center? Center is nothing but origin 0 comma 0, and the radius 4 can be written as 2 square. Therefore radius is 2. And we make a note that y is equivalent to plus root of 4 minus x square. Therefore y is positive. So in this we can draw a circle. Okay, so this is represent only y value should be positive. So here y value here positive and here are all y value is negative. So 0 to here in this side. So this is the equation of circle with center, origin and radius is 2. So minus 2 to plus 2 and here 0 to plus 2 above the circle. So from this diagram, what are the possible values x can take? Minus 2 to plus 2. So x can take minus 2 to plus 2, nothing but domain. So domain is nothing but minus 2 to plus 2. And what about range? So f of x can take, so here y value is 0 to 2. So radius is 2. So 0 to 2. And this is the diagram. And fourth one, sketch the graph of the absolute value function f of x is equivalent to x if x greater than or equal to 0 minus x, x is less than 0. think this is nothing but absolute value function. It is denoted by mod x. Everybody know about this. So the given function is nothing but mod x. So this is when x is negative, if mod x can take minus x. When x is positive, mod x can take x. So first we see 0 to infinity. So what about positive side? Function is f of x is nothing but plus x. If we put x is equivalent to 0, f of x value 0. If x is 1, f of x is also 1, 2 and 2. So we plot this, we can get this curve, this line. Similarly, what about in the negative side? F of x is nothing but minus x. So when x is 0, f of x is 0. When x is minus 1, f of x is plus 1. When x is minus 2, f of x is plus 2. So 0 comma 0, minus 1 comma 1 and minus 2 comma 0, minus 2 comma 2. So we can draw this, we can get this. So this is the graph of absolute value function mod x. And one more problem we will see now. So sketch the graph of the function f of x, and it is defined by when x is minus 1, the function is 1 plus x. When x is minus 1 to plus 1, the function is x square, and x is greater than or equal to 1, the function is 2 minus x. So here we have three functions. So minus infinity to plus infinity. So up to minus 1, one function is given. So namely 1 plus x, and minus 1 to plus 1, we have x square, and above 1 is nothing but 2 minus x. So first we consider y is equivalent to 1 plus x, first function. So these are all defined only in minus infinity to minus 1. For example, if you put x is equivalent to minus 1, what will happen? Y value is 0. That is 1 minus 1, we can get 0. When we put x is equivalent to minus 2, what do you get? 1 minus 2, nothing but minus 1. So on, so on. One more point. If x is equivalent to minus 3, so we can get minus 2. So just we plot here. So x is minus 1. So y value is 0. So here this one. And x is minus 2. Y value is minus 1. So here, and likewise we can draw this, so we can get a line. Now what about the second one? Minus 1 to plus 1. So the function is y is equivalent to x square. Okay, namely this is the parabola, right? I think this is upward direction we are having. So here if you put x is equivalent to 0, what do you get? We put x equal to 0, y is 0. We put x is equal to 1, y value is 1. We put x is equivalent to minus 1. What about y value is plus 1? So in the graph we can draw 0 comma 0, here 1 comma 1, right? So minus 1 comma 1. So it's a parabola. So don't write don't join by a line. So it's a parabola, we know. So we can draw like this. And finally, when x is greater than 1, the function is y is equivalent to 2 minus x. So x is 1, y value is 1. We put x is equivalent to 2. What do you get? Y value 0. So we plot this 1 comma 1. So 1 comma 1 here, and 2 comma 1, x is 2, y value is 0, and so on. We can get this line. So this is the graph of the given function f of x. Now we see increasing and decreasing functions. So what is increasing and what is decreasing? So first we see what is increasing function. So a function f is called an increasing function in its domain D if f of x1 is less than or is equal to f of x2 whenever x1 is less than x2 and x1 x2 belongs to x2. So we can see the graph, that is if x1, we take 2 points x1 and x2 in the domain, x1 is less than or equal to x2, which implies f of x1 is less than or is equivalent to f of x2. That is, if x value is increased, then f of x values also will increase. Then the function is said to be increasing function. Similarly, we can define decreasing function. So a function f is called a decreasing function in its domain D if f of x1 is greater than or is equal to f of x2 whenever x1 is less than x2. That is, if x1 is less than x2, then f of x1 not less than, greater than f of x2, greater than or equal to f of x2. That is, when x values are increased, x1 is changed into x2, whereas f of x1 value is decreased into f of x2. So value is decreasing whenever x is increasing. So this is nothing but decreasing function. And we make a note that increasing and decreasing functions are also called monotonic functions. So we see some examples. So first we consider the function y is equivalent to x square. So it's an increasing function in the interval 0 to infinity. I think if everybody know, we are familiar with this curve. Y is equivalent to x square. It's a parabola, so upward direction, right? So in this, we look at this in the graph 0 to infinity, right hand side, it is increasing. So increasing in the interval 0 to infinity, whereas in this it's a decreasing function. That is, x value is increased, f of x value is decreasing. So here, second example, consider the function f of x is equal to x cube minus 4x in the interval -1 to 2. So take this curve and we plot this. We focus on this interval -1 to 2. So -1 to 2, here you consider -1 and 2. So we can take only in between this interval. We plot the given function in the interval. So now we look at this. So here in this, so it is increasing up to this value, I think 1.2, right? So from the diagram, the curve decreasing in the interval -1 approximately 1.2. After that, it start to increase. The curve increasing in the interval approximately 1.2. So we consider only in this interval. So decreasing first and then increasing. Thank you for watching. Please like, share and subscribe. Thank you.